Okay, the sections on symmetry are kind of hard to do on paper because I can't draw this stuff and rotate it and everything. I think it was pretty easy sections. There's two types of questions. They can ask for lines of symmetry, so where they just want you to tell them how many mirror lines there are in the shape. And then rotational symmetry is going to ask you for an order. What is the order of rotational symmetry in this shape? Then you just see how many times can I turn it so that it still looks like itself. How many times can I turn it until I have the shape in the same position as I did at the start? Anyway, if you need help on this, you really need to look at the book. Then we had polygons. Polygons. A polygon is a shape with many sides. They don't necessarily have equal sides. I drew one here that is has all different interior angles. The interior angles are inside the shape, right? So it's not a regular polygon. It can be slanted, crooked, funny shaped. What you need to remember is that, well, when a polygon has three sides, that's a triangle, right? And we know that the sum of the interior angles in a triangle are 180 degrees. So it's the number of sides minus 2 times 180 degrees. This is that formula that you learned. This is actually 1 times 180, right? But it works the same when you have a shape with 4 sides. The sum of the interior angles can all be different, but the sum of the angles is going to be 4 sides minus 2, which is 2 times 180 is 360. We learned that before, that all the angles in a rectangle, well, in this case a polygon, so the angles aren't all going to be 90 degrees necessarily, but still they're going to add up to 360. When a shape has 5 sides, it'll be 5 minus 2, which is 3, times 180, which equals 540 degrees. And I showed you in class that you can prove that this is true because you can turn this whole thing into all triangles. My shape here has 6 sides, and I have 1, 2, 3, 4 triangles in there, really. So 4 times 180 degrees in this shape. This would have 4 times 180 degrees. And I said it has 6 sides, so if we use this formula that we have here, it would be 6 minus 2 times 180. And yeah, that is 4 times 180. So I didn't actually want to repeat this. I showed you this in class, but this is the proof of this formula, that in general terms we would write sum of interior angles equals the number of sides minus 2 times 180 degrees. We need that addition. N represents the number of sides. So in any polygon, no matter how many sides it has, you can find the sum of its interior angles with this formula. Okay. When a polygon is regular, that means it has all the same sides, right? In a polygon, so I tried to draw a regular polygon here. It's not actually very regular looking, but imagine these angles are all the same, and all sides are the same, right? That would make it a regular polygon. These interior angles are all going to be the same size. The interior angles of an n-sided polygon the size of the interior angle is going to be 180 degrees minus 360 degrees divided by the number of sides. So in my 5-sided regular polygon, that would be the size of this interior orange angle would be 180 minus 360 divided by I'm doing this backwards. I shouldn't be doing this like this. I don't have time to fix it. Divided by 5, which would be 180 minus 360 divided by 5. Ooh, that's 60 plus 12, 72. And that would equal 108 degrees. So these inside angles are each 108 degrees. The exterior angles and I should have done the exterior angle first before I did the interior angle, but you see that the interior angle and the exterior angle are on a straight line. They need to add up to 180. The exterior angle of an n-sided polygon is always 360 divided by the number of sides. Remember the little ladybug walking along the edge and turning, and here walking and turning and turning and turning. So after it's turned all these exterior angles and gotten back to its original position, the ladybug actually rotated 360 degrees, which is how you can imagine that these angles, these exterior angles added up together, need to equal 360 degrees, which is a full rotation. That's why 360 divided by the number of angles will give you the size of one of these angles. So in our 5-sided regular polygon, that would be 360 divided by 5, which we found up here is 72 degrees. When we realize that the exterior angle is 72 degrees, then to find the interior angle, we just do 180 minus that exterior angle, right? Which is here, the formula for finding the interior angle is actually 180 minus this expression here that we used to find the exterior angle. So this bit is the exterior angle, 180 minus the exterior angle is the interior angle. Sorry for doing that backwards. Should have done the exterior first and then told you how to find the interior. So much for polygons. Yes.